My name's James Lane. I'm a front-end developer specializing in graphics for the front end. And I'm going to be presenting a talk on new graphics features and improvements we've been making over the last year. Just from the outset, please feel free to post any questions or comments that you have in Pathable, and I'll try to get to them at the end of the talk. There's quite a lot of material to get through here, but we'll see how we go. Okay, so yeah, as I said, I'm a front-end developer, and in this talk, we're gonna look at new features and improvements we've been working on over the last year. Many of these features are to improve the aesthetics of the product. I'll be introducing material shading, which does this. There are features like new light directives, which make it easier to express yourself in the language, to specify lighting. There's new functionality that'll be introducing, new offset and cap forms for dashing. There's the finalization of AxisObject so that it's in the canon of Mathematica. It's no longer experimental. Also a new named VertexTextureCoordinate specification for being able to do screen space vertex texture coordinates. And then we've added more options for graphics and graphics 3D that you can query using absolute options. And finally, I'll be looking at some speed improvements, which we've made for our software rasterization for Mesa particularly. I am going to also just stop sharing my video. One of the new features that's been implemented, this is been a combined piece of work by Yusu Liu, Charles Pu, and Alex Schedelbauer on trying to make the front end draw more realistic surfaces using a more realistic appearance. And this is getting into physically based rendering and allows us to have prettier pictures in the front end. I'm not going to dive into physically based rendering. Alex Schedelbauer is going to be giving a talk tomorrow on physically based rendering in 3D at 11 o'clock tomorrow. And yeah, I'd encourage you to go to that. It's a great talk on all the aspects of how this physically based rendering has been implemented across the front end and the kernel and the physics behind it. There's also a really good tutorial for it as well. I'll just refer you to those. But I'm just basically going to introduce material shading and how to get it using. So basically what it is we use shaders and they model the interaction of light with materials according to certain optical properties of those materials. And Alec will talk about that. But what we've provided is basically a set of materials, common materials like gold, and you can query them and say, I want the material shading of gold. This is and if you look at what that provides, it's got these set of optical properties for gold that we use to simulate rendering a surface so that it looks like gold. To the next slide. So how do you use this in the front end? A lot like you would apply a color to a surface, you'll just say material shading, and you'll specify your surfaces after that, and they'll take on this material shading. So you can basically have a sphere that looks like it's gold. Things that you can do with the material shading is you can also change the base color of that. So here I've got a material shading using plastic. Its kind of default color is blue, but I can say that I'd like that in a red. And then you can do things, much more advanced things, where you can create your own custom materials that are much more realistic looking, and you can actually bring in textures for each of these properties, these optical properties of a material, and you can generate quite complicated real world looking surfaces. You can apply material shading to your plots by putting it into the plot style option. And here you'll get a plot that looks plastic. And one of the things I don't know if you've noticed, but in these examples, I've been using 3-point lighting. This is a new named lighting option. And basically all it's doing is it's bringing in 3 directional lights that are like this. But as I said, please attend Alex's talk tomorrow. He'll take you into the heart of this physically based rendering. And so kind of finishing off with lighting here, we've implemented what lighting directives. And we've done this to provide more flexible way to express the lights, and it's also more convenient in many ways. And you'll see that as I flesh out this example. So here's an example. Instead of using the lighting option or styling a sphere with different lights, you can simply just specify I want an ambient light, a directional light, a point light, and so on. Just one thing to say here is these forms or these directives, they match up with the current way the current syntax of the options. So if you had ambient light, you specify color just like you would the option, and so on. And then, so you can get this surface here. It's been lit by an ambient light. It's got the directional light, a point light, and a spotlight here. But I'll go into this in more detail now. So one of the features of these lighting directives is that they're additive, and our current lights also all get added up and applied to the different surfaces. But if we've got a simple example like this, I've turned off the kind of the default automatic lighting, and here I have 2 spheres. So at the moment there's no lighting, they're black. If I introduce some of these directives, I'm going to introduce like an ambient light, a spotlight, and a directional light. Then let's say I introduce the first 2. So here I've introduced an ambient light, which is making these a little bit more gray, and a spotlight, which is this orange light on it. And you'll see they're being applied to both of these spheres. The one's just a grazing, the spotlight just grazes this lower sphere. But and these lights are additive. So if I add a directional light as well, it gets applied to all these primitives that follow on after those directives. So now they're both getting these lightings. But now if I add additional lights after this first sphere, the first sphere will be lit with these first few lights. So you can see it's got the bottom sphere's got the orange, the red, and the gray mixed together. But this sphere here, the larger one, also has a blue directional light and a green point light falling on it. So this is really useful because now you can have groups of lights affecting groups of primitives, and you can add these lights to get your different lighting. So it's more convenient and flexible in applying different lights to different surfaces. So another aspect of this additive is, in the previous example, you would have seen I turned off the lighting, so the automatic default lighting, and that gives us kind of these 4 lights falling on this. But the directive lights are additive. They will, if we don't turn those lights off, they'll just be added to it. So here I'm just going to add a red light into the mix, and that falls on the sphere. So one of the things we'd like to be able to do is as you've got these lights coming in, you might want to have a surface that turns off all the previous lights and starts again. So for instance, in this example, I've got that previous red light and the automatic lighting. And if I'd like to switch off all that lighting and kind of start afresh, I can use this lighting form none, and it'll clear all previous lights that have gone before, and it'll apply the directional lights that are specified afterwards to that sphere. we also provide the option to not only clear all the lighting, but you can clear a specific type of, you can clear like all the directional lights or all the spotlights. So for instance, in this example here, I've got an ambient, a spotlight, a directional light, and a point light falling on this sphere, and I can turn these off one by one. Here I'm going to turn off the directional light, which is the red light. I've just taken that off. Then I can take off the, say like the spotlight, and that goes off. And if I take off, if I say, I can also turn off the point light, for instance, by saying point light none. You don't have to do this system, by the way. That was just while I was developing, and I didn't save the notebook with the new version. So in that previous example, I was turning off the spotlights, the point lights, and the directional lights, but ambient lighting works slightly different. We only have one ambient light source. And so whenever you specify an ambient light, it overrides the current ambient lighting. So in this example, I've got the automatic system lighting, and I've turned off the spotlights, directional lights, and point lights. And now if I apply any ambient lighting, that's going to override the current lighting. So ambient lighting isn't really additive to other ambient lights. So directional lights, they get added up and applied to the following surfaces. The ambient lights that you specify will override the previous ambient lighting settings. So here, for instance, I've said I want gray level ambient lighting, and we get gray lighting. And if I specify pink ambient lighting, I get that. And if I specify I don't want any ambient lighting, it should turn that off, and we have no lighting in this example. Into some new features, we've improved our dashing. We can now specify an offset in a cap form, and so all this is it's two added arguments to the existing dashing and absolute dashing forms. You can specify an offset magnitude or length and one of the three cap forms. Here's an example of this. So the dashing, you can shift how the dashing falls across the primitive that it's on. So here I'm just adjusting that offset parameter. Here I've got dashing, and I'm just adjusting this offset and the offset of the absolute dashing. One thing to note is dashing uses the offset that you specify here as a fraction of the graphics width. And for absolute dashing, it's in printer points. It's an absolute magnitude. Then the other feature we've added to dashing is that you can now specify the cap form of the dashing segment. So each dash here can have its segments using either end and start with a rounded endpoint, or a butted endpoint, or just a square one. So this is another aspect of that, another feature that we've added to this. This dashing in these new forms can be used to dash your edges. So for instance, here I've applied the dashing to these different edges of these primitives. Dashing also works in 3D and with vertex colors. So here we've got a line with different vertex colors at the different points of the line. You can change the cap forms of these lines, and we can also adjust where the dashing is, how it's offset along that line. One of the nice things about this dashing as well is that it's exportable. So I'm going to share, here's my home directory, and I'm going to export. Here I've got some dashing. I'm going to export it to common formats like SVG, EPS, and so on. And then if I go along to that directory, we would see those exported, that dashing exported, and I could, for instance, bring that into any editor of those or viewer, and you would see the dashing coming through. So here are some nice examples that Tim Schedelbauer put together, and you can just see you can create really nice dashed line segments in 2D and 3D. So very, very nice functionality here that is hopefully going to be useful to you. We've made AxisObject first-class front-end primitive in version 13.0. It's undergirded by the kernel as well, so it's no longer experimental. We've tied down all our options and the syntax and how we wanted it to work. So this is first class in version 13. Just a quick recap: AxisObject is in last year's talk it was called Axis, but we've called it AxisObject, and AxisObject is much more versatile than the axes you can get from Frame or from Axes, and it's and you can create multiple customizable axes. The one thing I'd like to say here is that I'm not going to dive into all the examples of and uses of this. Minsang Peng, he presented a really nice talk yesterday, and he's got some visualizations that make use of this. But what I'd like to just take you through is the options that we have to really customize your axes. So the first part is you can draw axes, you specify the path, and the one thing here is we allow you to put these primitives like half line, Bezier, B-spline curve, and circle into AxisObject, just like you would, for instance, in an arrow. And so you can get all these different kinds of axes. Circle is now also part of that in that arsenal of primitives you can feed to AxisObject. We've got these standard or these helpful forms for quick horizontal and vertical axes, which you can use. I'm kind of going through it quickly because there's a lot to be covered. Part of AxisObject is how do you map your values across your axis, and we do that typically by this second argument. So after you've specified the curve or the line of the axis, you specify how you want values mapped to it. And so here I want this axis to run from the values to run from 0 to 10 across this axis, and these values get tied into these points for a line. You can also specify, for instance, at the point 0 along this axis, I want the value to take on or 10 to be mapped to that point, and at 1 on this axis, I want the value to be mapped to 20, and then the other values get interpolated across that. And so that's basically just mapping the values across your axis. Then we provide this plethora of options to customize everything on your axes, from the tick lines to the tick labels to the orientation to the styling and so on. And examples are really useful. Probably one of the most powerful features of the AxisObject is the use of tick positions to do your tick placements. And with tick positions, we can do this kind of hierarchical control of ticks. So here I've got tick positions, and I'm saying I want a set of ticks to run from 1 to 4 in increments of 1. Then I want another set of ticks along this axis running from 0.5 to 5 at increments of 1. So that's going to be these guys. I want a set of ticks running from 0.25 to 5 at increments of 0.5, and so on. And this last one says I just want a tick at 0 and at 5. So there's a tick at 0 and at 5. And now what happens is the other options can associate what they want to do with it. So for tick labels, I've said this first set of ticks, these large ones, must just take on the automatic numbering that we do for ticks. The second set of ticks must use these tick labels, and I've actually labeled them with letters. The next one I've just said just label all the ticks. So normally we only label the major axis or major ticks, so minor ticks don't get labeled. But in this case, I said I do want them labeled. So I specified all. And then the last one, I just said none, I don't want any ticks. And then tick length also goes along with that. So the first set of ticks must use scaled lengths of 0.1. The second set of ticks must use offsets, an offset length, which is an absolute length of 18 printer points, and so on. And so you can have this hierarchy of ticks, and you can control what you want to happen to each of those set of ticks. So we find this is really useful. One of the features we've also added to this is collision avoidance. So we try to hide tick labels that would overlap other axes or other tick labels. So in this case, here I've got a horizontal and vertical axis, and normally we would have drawn, or previously we would have drawn the ticks for 0 on both of those axes, but because they would overlap each other, we hide them. And you can see if I scale this, if I make it smaller, for instance, as the ticks start to get closer to other ticks, they start to disappear as they overlap them. In this example, you can see it clearly. Those in between ticks should be hidden. There you can see they disappeared there. So we detect ticks or tick labels that overlap other tick labels, and we've got this ability to hide them. We can control the placement of the axis label. There are a whole plethora of options here, but you can place it above, below, before the plot, after the plot, at the start, at the end of the axis line, or at a specific position along it. We also allow you to rotate your axis label and your tick labels. You can have them running parallel to your axis, horizontal, vertically, perpendicular to your axis, or you can specify a degree, degrees, or an orientation for them. Also, control of your tick direction. You can say I want ticks inward, ticks outward, or I'd like my ticks even to straddle the axis line by using inward, outward. And also you can have scaled or absolute lengths for your ticks. We also provide options for, as you would have seen this earlier, but tick labels, you can specify what your specific tick labels are along the axis, and you can specify your tick label positioning. And by that, in this example, for instance, here, you can say, I want my tick labels to be at the base of the tick line, or at the tip of the tick line, or I want my tick labels to be before the tick line or after the tick line. So we customize, so you can customize how your tick labels are placed. This is also a new feature. We allow you to change the way an axis object influences the range or the graphic. You can let an axis object influence the plot range, or it can influence the image range. If you'd like for multiple axes which you'd like to sit outside of the graphic, you can then specify image range, and they can sit outside. Or you can say none, and if they're outside the graphic, they'll just drop away. Min Sung Ping had a really good talk on scaling functions, but here's an example of using scaling functions to get a log scale along your axis object. And then there are a whole set of styles to style the axis line itself, or the axis labels, or you can set the base style, and it changes the style of the axis line, the tick lines, and the tick labels. So I'm going to stop there. We're running out of time, but axis objects are really useful, and you can customize your axes now. And we're just encouraging people to use it and try it out. What a very cool aspect of Mathematica is that you can actually query your graphics, and we've added a set of new options for graphics and graphics 3D that you can now query. So you can say, for instance, if you've got a graphic, you can say, using absolute options, show me what the aspect ratio of that graphic is. Or you could query the image size of a graphic, and using absolute options, you can here I've queried the image size and the image padding, and it's telling me that's what's happening to the graphic internally or under the hood. And so you can do the same for the plot range and plot range padding. Another thing you can query now with your graphics is the rendering time. So if you evaluated this, it would render it. In this example, I'm rendering it, and I'm querying how long it takes to do that render, and that's done by graphics rendering time. So if you use graphics rendering time on something that's not a graphic or that doesn't work, it'll just return failed. But this ability to query your graphics is really useful, and we've introduced that. A new vertex texture coordinate or named specification that you can use for vertex texture coordinates. Previously, you could say automatic. Now you can say flat, which does your vertex texture coordinates in screen space. In this example, I'm just contrasting the two. So on the left is the automatic, and on the right is the flat vertex texture coordinates, automatic texture coordinates. And you can see the automatic one, the vertex texture coordinates, they kind of rotate with the graphic as I rotate that. But the screen ones, the screen space, those texture coordinates are just kind of moving around on the texture. So the image stays more static there. Also changing the aspect ratio. It's mapping the sides of the texture for the automatic case, but the screen space one, the squashing, you don't really see it so much. Then finally, just to mention, we've put in some improvements for our software rasterization. We've upgraded our version of Mesa to 20.2.6, and this can give up to 8 times speedups for some small, simple graphics in 3D. And we've also introduced an option to change this, whichever driver or the Mesa driver that you'd like to use. I'm going to, in presentation, just show you where to find that. So if you were to go Format, Option Inspector, and you went to Rendering Options, you would find this option called Preferred Mesa Driver, and there you can specify if you want to use OpenSWR, LLVM pipe, or soft pipe. And so you can actually change the Mesa driver that you're using. OpenSWR is only for Windows though. And this can give certain speed ups for instance, for rendering in the cloud or for cloud rendering. We also allow you to specify the number of samples to use for anti-aliasing in Mesa. So you can, at the moment, I've got in my front-end session, I'm using 2 samples, but you can go and set the Mesa anti-aliasing samples, and it should help you to get a better quality of rasterization. And I'm going to, that's it for the talk. I'm just going to switch over and have a quick look at Pathable to see if there are any questions. Okay, questions. Are there plans to support global illumination in graphics 3D? We kind of have been moving more towards that. There is the ray tracing project, which should contribute to that. Alec and them have done some stuff with ambient occlusion. But yeah, so it is something we have been wanting to do. So maybe we can do that in the future. Would be nice to combine vertical lines with fill. I'd like to be able to define highlight regions on a bell-shaped curve. I think we could do that. There's a tick label function, yep. So you can actually specify what tick labels you want for AxisObject. what is a major tick versus a minor tick using these new tick specs? That would be if I did something like, if I go back to Axis. So here, just looking at this example here, you can see your major ticks are typically your first one or your first specification. So for tick positions, if I grab, let's grab that, this example. So if I had, I'm just going to make a copy here. If I have just say 2 tick positions, and I'm just going to clear everything else. So this first specification would be the major ticks, so those guys, and the second one would be your minor ticks, those guys that follow on there. So whatever your first tick specification are your major ticks, and the second specification are minor, and you can have more, but then our default for the two cases, major, minor ticks. Is collision avoidance limited to the new AxisObject? It is limited to the we do collision avoidance on axes and frames. There are certain rules that govern when we hide ticks or tick labels on those, depending on how close they are to each other. But for AxisObject, we've got some special code in there to detect these overlaps, because the axis objects, they're not just simple horizontal or vertical lines. They could be Bezier curves now or so. So there is collision avoidance on the others to some extent, but it's a whole new system, especially for axis objects in version 13. Yeah. How would you get access control for like list plot? At the moment, I think you'd have to mix them. So you'd use show, and you could mix graphics with list plots and so on at the moment. And then presumably access objects can appear in an epilogue or prologue. They should. Yeah, my boss got that one. That looks like all the questions for now. Would be nice to just be able to do axis object. So that's interesting that you would say that. And there are some requests from the kernel to be able to do that, especially in terms of axis objects. In the front end, they know about the plot range and other details which would make that very useful to them. Ray tracing, we've been really busy with all these other features, but it is extensible. We could do it on Windows and Linux. OpenGL would allow that. It's got interop with Vulkan, which would allow ray tracing there. And on Windows, DirectX also provides interop with DirectX 12, which would also allow us to do it there. So hopefully over the next year, we can dig into the ray tracing a bit more. Jeff, yay, those are good graphics cards, and I'm sure we'll get back into the ray tracing this next year. I hope so. Thanks, guys, for listening and attending the talk. I have uploaded the slides for this. This is very much an introductory. I just wanted to introduce the new features, but feel free to follow those references or dig into the docs, and they'll help to flesh out the functionality I've explained more. Yeah, and just thank you for attending the talk, and hope you enjoy the rest of the conference.